Hello, we're doing our notes today on 16.1 Radian Measure. I just finished the video and it had no audio. So right now I'm going back to my video and I'm just trying to put audio over my video. So it'll be a little bit fast going through, but you'll be able to obviously pause on your own with what you need to do. All right, so we have our definition for a radian. We talked about last week how we could convert, or we did not talk about converting. We changed on our calculators the mode to degrees instead of radians. So now we're going to start talking about what radians are. So a radian is an angle with its vertex at the center of the circle that would intercept an arc on the circle equal in length to the radius of the circle with a measure of 1 radian. So in geometry, you talked about arc length when talking about circles. So that's what we're going to also talk about here. So I drew a little circle up in that right corner, looked at a little angle. So the angle in degrees, we just do the measure, but then that little green blob I put there would represent the length at that part. All right, so that's going to be your measurement in radians. If you remember back to what the circumference of a circle is 2 pi r for the formula. And since our definition said the radius of the circle is 1, so our radius would be 1. So that means our circle going around our coordinate plane, that's 360 degrees, could also represent 2 pi radians. If I divide each of those things by 2, 180 degrees would also equal pi radians. So we're going to use that fact in the problems that we're going to be doing today. All right, so the first example, we're going to convert degrees to radians. So if I have 45 degrees, I'm going to use my conversion factor that 180 degrees equals pi radians. So just like in science, you want to get rid of the degrees, so the degrees goes on the bottom to cancel out. I want it to be in radians, so that goes on top. So I put pi radians over 180 degrees. So that would cancel out my degrees, and I'd be left with 45 pi over 180. You will want to simplify these fractions. So then I'll need to divide each by the greatest common factor, which would be 45. So that would leave me with pi over 4 radians. All right, for number 2, I have negative 270 degrees. So I'll go ahead and take negative 270 times pi radians over 180 again. And so I have negative 270 pi over 180. Once again, divide each by their greatest common factor, which would be 90. And then you're left with negative 3 pi over 2. So if you have negative degrees, you will also have negative radians. So if you think about our coordinate plane here, that would represent negative 270 degrees. So it's still that measurement of that arc at negative 3 pi over 2. So that negative is still moving it in that direction. All right, we can also convert radians to degrees. So if I give you 9 pi over 4 radians, I'd have 9 pi over 4. Now I'm doing 180 degrees on top, and that would be over pi radians. I'm canceling out the pi, or I'm canceling out the radians to get degrees. All right, so the units of radians would cancel out, and then I'm taking 9 pi times 180 over 4 times pi. The pi's on top and bottom would also cancel out, so really I'm just taking 9 times 180, dividing it by 4 to get 405 degrees. Another example here, so negative 5 pi over 6, so same thing. If I have a negative angle in radians, it will still be a negative angle in degrees when I'm done. So I'll take negative 5 pi over 6 times 180 degrees divided by pi radians. That would get rid of my pi's. So I'm taking negative 5 times 180, dividing that by 6. So I get negative 150 degrees. All right, so the last thing that we'll do here, you might be asked to find the exact value of something. So just like we did last week, so if I ask for cosine of 5 pi over 4, that's similar to what you had to do last week. but we're going to need to convert that to degrees. So I'll take my 5 pi over 4 times 180 degrees divided by pi, so I get 225 degrees. All right, so now I'm trying to figure out cosine of 225 degrees. In my coordinate plane, that means it would land in quadrant 3. Finding that reference angle, I would take 225 minus 180, so 45 degrees would be my reference angle. So if I use my 45, 45, 90 special right triangle, that means my ratio would be square root of 2 over 2. But remember, you're in quadrant 3, so that means both x and y values are negative. So if cosine uses the x value, that would make this negative square root of 2 over 2 for my final answer right here. Our last example we'll take a look at. So I've got tangent of 2 pi over 3. I'll go ahead and convert that to degrees. So I get 120 degrees. I will put that where it needs to be on the coordinate plane, so that's in quadrant 2. I will find the reference angle, so 180 minus 120 would be 60 degrees. I can use my 30, 60, 90 special right triangle. I can use the tables, the tables we've made. All right, so then square root of 3 over 1 would be tangent for the opposite side over the adjacent side. So that means tangent of 2 pi over 3, I would use square root of 3 for my ratio. But since I'm in quadrant 2, that would mean my x is negative, my y is positive. And if tangent uses y and the x value, that would make it a negative square root of 3 and my final answer. And that is it for our lesson today. Thanks, bye.